Hello, I'm going to present Fiber Surgery. Our company is a robotic assistant for spine surgery. There are multiple spine diseases and most of them are resolved with a procedure called vertebral fusion. It consists on inserting a couple of screws in the pedicle of the vertebra and connecting them with bars. It's a very complex procedure with dramatic consequences if there is any mistake, and in some cases a new surgery is required. It's done by very well experimented surgeons using anatomic references, X-ray, navigation, and in just a few cases, any kind of robotic assistant. The market of the spine is growing. There are 7 million screws inserted per year, and only 1% use any kind of robotic assistant. Also, the robotic market is growing, where spine is a niche market where accuracy is required. There are 3 competitors, and the most important characteristic is that all of them use optical tracking system for following the patient. So we have done a robotic assistant, but with a new mechanical tracking system that allow us new performance, different bone connection, and optimizing the surgical procedure. Here we are going to see a video of how the system works. First of all, we acquire a CT scan for the patient, and with this is a mix of human cadaver and phantom. With that information, we have a software for planning. So here we can see the screws, and we define in whole of the axis where the screws we want to be located. We can modify the length, the width. So here the surgeon defines how he wants or she wants the surgery. In the operating room, a couple of weeks later, we attach a clamp. Here we see how the attach is clamped in a human cadaver, and is very well fixed because it's the new reference. In that clamp, we use some fiducials, and here we can see that fiducials, and with the X-ray that is always in the operating room, we have several spheres, and with this information we correlate the 2-dimension image with the 3-dimension, so we know where is that clamp. Later, our robot, here there is a guide, and through this guide we insert a cannula, and through the cannula the doctor can insert the screw. So the screw is in the pedicle with a minimally invasive procedure. In this case, the doctor is going to see if everything is working properly, but he decides to move the patient. And as you can see, the robot corrects the position. So the robot always gives you the right trajectory. So with the breathing or any movement, the robot is always following the patient. So here we go. So there are several advantages. Better accuracy than our competitors, so it's less risky, it's safer for patients and surgeons. We reduce the cost because we reduce the time of the surgery between 15 and 20%. We reduce, because it's a minimally invasive surgery, the time in the hospital from 9.4 to 6.8 days, and it's a technology that allows us future applications. So we have tested in phantom, also in human cadaver, so the technology is validated with these trials and with the patents. In the market, we have supporting letters. We are members of the American Society of Spine, and we have validated all with 2 different notified bodies. The team, nowadays we are 12 people, and we want to be 17 at the end of this year. A couple of PhD and 10 master engineer. It's a multidisciplinary team. Focus on business, quality and regulation, robotics, software, and mechanical design. We collaborate with 3 different hospitals, and these are the doctors, the main doctors that we collaborate in this moment. And we are creating a medical advisory board. In Europe is almost done with people from France, Italy and UK, but in US is something that we want to do in between this year and this year. So our roadmap, next year we'll get industrial solutions, we begin the clinical trials, so we'll get the certification in 2021. After that, we'll focus in American market with the FDA certification. Financing, we have several partners. In the health sector company, we have 1 partner in health sector. Some partners are industrial companies or venture capital. In this moment, we have got 1.2 million euros in October, and it's supposed that we'll get 2.8 more between 2019 and 2020, depending on some milestones. We are still looking for other 2 million euros in order to get a certified product and install it in 3 hospitals. In this moment, we will have to look for other funding, probably US money, between 12 and 15 million euros in order to go to international. So there is one opportunity because there is one need, is the market moment, a product with a clear advantages and patented technology and multidisciplinary and motivated team. So that's why we present to you Cybersurgery. Thank you very much.